Hello, and welcome to another webcast brought to you by Digital Dimensions, Ford Engineering Solutions. Today we're going to talk about a very important topic, communication using SOLIDWORKS. At the end of the day, our primary job is communication, whether we're communicating with the end customer, fellow clients, or the shop floor. The bottom line is our communication needs to be clear, concise, and accurate. So to cover this topic, I've broken up communication tools into 4 areas. The first one, communication tools for supporting documentation. This would be any supplemental information that travels with your part. So the SOLIDWORKS tools that enable us to do this are things like the ability to insert objects, adding hyperlinks. There's an item called the design binder that we can put all of this stuff in the design binder. There's also a Word document called the design journal, and each SOLIDWORKS file carries file properties. These file properties, of course, can be pulled into a drawing, but more importantly, they can be searched by. The second area for communication tools is process documentation. These are things like renaming features and/or dimensions while you're making your model, maybe adding descriptions and comments to those same features. We have the ability to add sensors to verify design intent, so if a specific rule is violated, we'll know about it. Folders can be added to the feature tree to group like features together, or to an assembly tree to group like components together. We can more accurately represent casting parts and/or make from components using the insert part function on a new part file. We also have the ability to add tags. Tags is the function in which we can select on specific components and basically group them, if you will, for later usage in search. The third area for communication tools is visualization. We have the ability to do things like add background images, take advantage of sketch pictures, including an auto trace functionality, in which case SOLIDWORKS will attempt to trace the outline of your sketch picture. Sketch blocks, this is the ability to take a fairly complicated sketch and lock it down or glue it in place, so SOLIDWORKS does not have to constantly calculate or evaluate the relationships within that sketch. We have display states. This is the ability to control how parts or assemblies are being displayed, and this is different than configurations. And to round out visualization, we have the ability to add decals. This is for things like part marking or product identification. And lastly, for communication tools, we have exports, whether we're communicating with other CAD users or exports for non-CAD users. Okay, first up for communication tools, supporting documentation. SOLIDWORKS allows you to insert objects. This basically gives you the ability to attach OLE objects. Okay, OLE is Object Linking and Embedding. It's a Microsoft protocol that basically allows me to attach a document into my SOLIDWORKS file, and then when I double click on that object, I'll be able to edit that file inside of the SOLIDWORKS interface using the registered program for that OLE object. Now keep in mind, this will only apply to the OLE compatible programs you have installed on your current system. When we insert this object, we have 2 options. We can create a new file. This will basically drop in a blank document of the chosen type, or you can create from an existing file. This basically allows you to embed an existing file into your SOLIDWORKS document. And again, if you double click on that existing file, you'll be able to edit it with inside of the SOLIDWORKS interface, pulling in the OLE compliant application to modify it. Keep in mind that as you embed these files, that this will increase the SOLIDWORKS file size by the amount of the file you're attaching. So for example, if you go to embed a 20 megabyte PDF, your SOLIDWORKS part file will now be plus 20 megabytes. So if you're planning on emailing stuff, you may want to reconsider. There is an option in here that allows us to add just a shortcut and not necessarily embed the entire file. This is called the link option. This will basically allow me to add a shortcut to the original document. But again, if you're going to be emailing this file to somebody else and they will need to see that 20 megabyte PDF, you'll end up needing to email it anyway. Now, one of the advantages to having the link option being used is if it is attached to a dynamic file, in other words, one that will be continually updated and changed by other people, then this shortcut will always be pointing at the new file that everybody has been updating. If you embed this into SOLIDWORKS, then the file that gets embedded is locked with that file. So even if there's duplicates out on the network, the file that's embedded in SOLIDWORKS was like a save as the day that you inserted it into that file. So for most items, I recommend using the link option. This is going to give you the ability to add a shortcut, if you will. Therefore, that document will be continuously updated. Every time you double click on the shortcut, it'll of course pull up the master document, the one that everybody's modifying. So whether you're using create from file with or without the link option, by default it's going to drop in a preview of that document. Now, to minimize the footprint on the SOLIDWORKS screen, we could use the display as icon option. This will basically drop in the document as an icon that you would see in Windows Explorer. Now, if you use the display as icon and link option together, then you basically get an icon representing the shortcut to the original file. And with that, we'll go into SOLIDWORKS to take a look at this. So over here in SOLIDWORKS, you'll see a part file that I downloaded from McMastercar.com. The first thing I want to do though is insert a new object. So from the Insert pull down, you'll find Object. And from the Insert Object dialog box, under Object Type, you'll see as I click on Create New, all of the OLE compliant applications that I have installed on my system. Here I'm looking to drop in an Excel worksheet. When I click on that, SOLIDWORKS tells me that my results will be a new Microsoft Office Excel worksheet object put into my SOLIDWORKS part. So when I hit OK, you'll see the Excel toolbars across the top of my screen, and here's my new worksheet. I can go ahead and start filling out my worksheet and so forth. Now, to return back to SOLIDWORKS, I just click in the background of SOLIDWORKS. And then maybe to see this, I can zoom out a little bit. And there's my worksheet. If I wanted to modify this worksheet again, just double click within the worksheet area and you can type some more. When you're done, click out. I'm going to go ahead and delete this worksheet because I want to show embedding an existing file. Now this create new, this worksheet only exists in my SOLIDWORKS part file here. So I want to go ahead and take an existing one rather than having to type all this in here. So let me delete that. Insert Object. This time I'm going to create from a file. And when I browse for it, you can see here I have a DWG file, which I also got from McMastercar for this very same ball valve. And then when I hit OK, SOLIDWORKS drops in this DWG file, and I can position it wherever I need it. I can even resize it. To modify the DWG file, just like the Excel worksheet, I can double click within the DWG area, and here it brings up my DWG editor icons. To get back into SOLIDWORKS, you just click in the background. If I wanted to see more of this screen, I could of course zoom in and double click from there. Or if I want to just use DWG Editor to edit it, as I zoom out here, I can right click and specify Edit with DWG Editor. This will launch the native application, and then I can modify it from here. To get back into SOLIDWORKS, I just close this document here. Next, I'm going to go and insert another object. This time I'm going to create from a file, and I want to link it this time. So insert as linked object. Now with this link, basically this is going to drop in a preview of my document, but it will be linked to the original. So again, this is going to behave just like a shortcut. So as I hit OK, SOLIDWORKS drops in this Excel spreadsheet. I got this from McMaster-Carr along with the DWG. And if I wanted to modify this, I just double click on it. You'll notice that this opens Excel, and from here I could add input. So on this column here I have availability, and this would be based on the sales rep I'm talking to try to get hold of these parts. It looks like the 2-inch is very common, so I can get it within a day. The 4-inch, however, is not very common. It takes them 2 weeks to get it. Let's say I was inquiring on the 3-inch, and they told me that it's going to take a good 7 days to get a hold of it. So I'll just type that in. Now when I go to close this, Excel is going to ask me to save changes to my Excel worksheet. After all, this is an external file. It is not embedded in SOLIDWORKS. It's an external file, so this is going to update the one on the network, or in this case on my hard drive. When I hit yes, this document's been updated, and to see it, you hit refresh. Occasionally you may need to save to watch it update. And from this I'll go ahead and move the Excel worksheet out of the way. And with that, we'll get back into the slideshow. SOLIDWORKS has an item called the Design Binder. This is basically a folder that can be found in the feature tree. And this is really the best way to attach documents to your SOLIDWORKS files. Some of the items you may wish to attach to your Design Binder include, but are not limited to, the following: material specification data sheets, engineering change requests or engineering change orders, assembly instructions, proposals, quotes, calculations, problem reports, problem logs, reports, specifications for purchased parts, or design failure analysis. In addition to the Design Binder, each SOLIDWORKS document contains file properties. The file properties should be information that's specific to that SOLIDWORKS file that can be used within the drawing title block, the bill of materials, and search functions when using SOLIDWORKS Explorer or PDMWorks Workgroup or PDMWorks Enterprise. Embedded in the Design Binder by default in every single SOLIDWORKS document is a design journal. This is a Microsoft Word document that by default are pulling in the file properties of file name, description, and material. So when you update the file properties to that SOLIDWORKS document, these properties are then updated and reflected in the design journal. Additionally, we can insert hyperlinks. These hyperlinks can be internet addresses or local links to your network drive. These hyperlinks can be embedded in a note or added to the design journal. And with that, let's take a look at some of this. Okay, to access the Design Binder, you first need to show it. To show it, right-click in the Feature Manager tree and specify Hide Show Tree Items. This can also be found under Tools Options for System Options under Feature Manager. And here for Design Binder, by default, SOLIDWORKS sets it to automatic, which simply means if there's items that somebody has put into a Design Binder, it will show up automatically. But by default, the new document has nothing in the Design Binder, therefore the Design Binder will not show up. So if I set this to show, my Design Binder will always show up in every new document so I can start using it. Now, the Design Binder is one of the most underutilized items within inside of SOLIDWORKS that also has the most potential. And as I hit OK on this, I can see my Design Binder. Now, to add an attachment to my Design Binder, you can right-click on the Design Binder to add attachment. This allows me to browse for the file that I'm interested in adding. And here I'm going to go ahead and attach the step file to the design binder. Now keep in mind that this step file is 1.216 kilobytes, which means it will add 1.26 kilobytes to my file, unless I use the link option. The link option means it will drop in a shortcut to the original step file. I'm going to uncheck link and just hit OK. Now, if I take a look under the design binder, you'll see the step file that has been put into there. Now, I also mentioned file properties. From the file pull down, when you go into properties, under the custom tab, here we can put in information about this file. So from the pull down here, I can specify the material, and then I can drop in a description. Additionally, any other information that would be specific to this part, I would want to add to the file properties. Again, this stuff can be pulled into your drawings as well as used in the bill of materials. Inside the design binder, by default, there is a design journal. It is a Word document. To open it, just double-click on it. This launches Word, and here you can see that it's pulling in the file name, which is the name of the SOLIDWORKS part. It's pulling in the description from my file properties, and it's pulling in the material from my file properties. And since I downloaded this ball valve from McMastercar.com, I went ahead and pasted the hyperlink into my design journal. This way I can find this part again if I need to. Additionally, I pasted in some other information that I found on that web page for this part. So if I'm ever away from the internet and I need to get more information about that part, as long as it's pasted onto the design journal, I'll be able to track it. Now keep in mind, the information that I put in this design journal is just one small example of the potential of this design journal. And when coupled with the design binder, the possibilities are limitless. And as you can see with these other objects that I've dropped in here, had I put them in the design binder, my screen would be less cluttered. Especially if I was going to use the display as icon option, create from file and insert as linked. If I had done display as icon, then it would just show me an icon here, and it would be far better to just throw that into my design binder. Otherwise, this icon is just going to sit there and get in my way. So the design binder allows me to attach as many documents as I like, and they stay away from my screen so it's uncluttered. And with that, we'll get back into the slideshow. Next up for communication tools, process documentation. This area of the presentation kind of covers the best practices when you're using SOLIDWORKS. For example, renaming features. You can rename features by slow double-click or selecting it and hit F2 on the keyboard. After all, at some point, extrude 29 kind of loses its meaning. So by being able to assign it a specific name, you can then readily identify it later on. If naming a feature is not enough to identify it, we can also add a feature description. In order to do this, you just access the feature properties. In addition to adding a description to your feature, you can also find out who created the feature and when, as well as when it was last updated. A third process documentation tool here is adding comments. You can right-click on a given feature and specify comment, add comment. Adding a comment would allow me to add special notes or instructions for the next designer that may modify my file or my feature. Adding a date and timestamp will let everybody else know who reads the comment when I made the comment. Another best practice for process documentation is renaming your dimensions. This will allow you to call out attention to a specific dimension when used with sensors, equations, and/or design tables. Now, a sensor is something that was introduced in SOLIDWORKS 2009. A sensor basically allows me to tell SOLIDWORKS to watch a specific dimension or mass requirement and to tell me when my requirement or my rule has been violated. it will show up like a regular feature error. So by renaming my dimension, when I add that dimension into my sensor, I'll be able to tell what dimension is talking about. Additionally, to document my process, I could add folders. This will allow me to group features together, either for machining operation or for convenience. When you group features within a folder, it does not change the parent-child relationship of your feature tree. And lastly, another best practice here, insert part. This allows me to start a new part and insert an existing part as the base feature. This allows me to accurately represent made from components. The best example I can think of is a casting. If I have a casting component that will later be machined, well, the original casting has its own part number. So too will the machined part. So the best way to document this in SOLIDWORKS is to have your casting model, and then when you go to make the machined version of that casting, drop in that casting as the first feature in that new part. And with that, we'll take a look at this in SOLIDWORKS. So for renaming a feature, I'll go ahead and open a new file. And to rename a feature, you just click on the feature in the tree, slow double click, and then type in your new feature name. Any feature or sketch can be renamed. I can choose to name each feature based on what operation may create it. So if this is a milling operation, and I can proceed to do that on all these features. And if renaming the feature was not enough to tell the end user about it, I can right click and go into my feature properties, and from the feature properties I can give it an additional description. Now, after I've given this a description, in order to see it, I need to show it in the tree. To show it in the tree, if you right click on the name of the part, you'll notice there's an item called Tree Display. From Tree Display, I can show the feature descriptions. Now, so long as the feature description is different than the feature name, it will show up in the tree. So as I turn this one on, I can see there's my mill cut 1 with mill cut 1 description. If I added a description to the base stock here under the feature properties, and I'll just call this stock material, now my description shows up. So I can rename features, I can rename sketches, I can also give a description to a sketch under the feature properties for that sketch. And you can see that description shows up in the tree as well. In addition to naming a feature and giving it a description, we can also add comments. To add a comment, just right click on the feature, go over to comment, and add comment. This comment, I could add a date and time stamp and then specify what I want the end user to know. Material may be substituted for balsa wood on prototype. Then I save and close. In order to see that comment, you just hover the cursor over the feature in the tree, and here you can see when I added the comment and what my comment was. Additionally, you'll notice that there's a comments folder at the top of the tree now, and this comments folder will show each feature that happens to have a comment in it. So this comment is similar to Microsoft Excel. When you right click on a cell, you can add a comment to let anybody else who's reading that document know what the equation in that cell happens to be doing. That's exactly what this can be used for. Maybe on this cut here I want to add a comment. Please check part number 12854 for fit before modifying. So if they're going to make changes to these dimensions, they should go and check out part number 12854 before making a change. So again, this is just one way of leaving little clues behind for the next designer that might pick up this part, or for yourself 6 months later when you come back to this part after working on 5 other projects. To group features logically in the tree, I could add them to folders. So for these here, I could specify add to new folder. So these cuts will be done on the drill press. And now I can see all those holes that are going to be done on the drill press. Another advantage of grouping items in a folder is I could suppress them all together or bring them back. Alternatively, I will need to bring back that chamfer. Now, had that chamfer been in that folder, it would have unsuppressed with the rest of the items. Next, I may want to rename a dimension. As I double-click on my stock feature here, I expose the dimensions that belong to it. When I click on a dimension, I look at the properties for that dimension over here on the left, and I can see that the current name is D1. Now, by default, the first dimension at a sketch or a feature is named D1. The second dimension is named D2. In order to rename this dimension, I can swipe over D1 in the primary value and give it a new name. Maybe I want this to represent the height. I can see that that's the name of the dimension if I double-click on the stock feature again, click on that dimension, and there underneath primary value I can see the name of height has been applied. Now I could do the same thing to the width. Just click on my next dimension. By the way, you could swipe over the entire dimension name, which, by the way, as we're talking about dimension names, you notice that D2 at stock sketch, since I had renamed the stock sketch, that is also part of the dimension name. But here I just want to call this width. And then to see that dimension name, I can hover my cursor over it or click on it, and that shows me the dimension names. Now, in SOLIDWORKS 2010, from the View pull-down, they moved dimension names here. It used to be under Tools Options, under General, the third item down, used to be Show Dimension Names. Well, now, as I mentioned in 2010, from the View pull-down, you can show dimension names. And it's down here about in the middle, dimension names. Now when I double-click on the stock feature, I can see the width and the height, and the unnamed dimension D1. Maybe that's the depth. To see these dimensions on all the time, you can right-click on the Annotations folder and show Feature Dimensions. Now I have quite a few dimensions on this one, so I'm going to go ahead and turn them off. But again, when you right-click on the Annotations folder, you can show your feature dimensions. So here I can see all my dimension names. Now, aside from having to click on the dimension to see what it's called, there is another tip I want to give here, and that is the link values. If I plan on using this height dimension in multiple places, when I go to change the height dimension, one of the options from the pull down here is add equation or link value. Now, if I wanted this height to be equal to something else, I could add an equation. I could say this height is equal to D1 at sketch 5 or whatever. Now, if I do that, in order to change the height, that would have to change D1 at sketch 5. Alternatively, if I wanted the flexibility to modify it either from the height dimension or from the D1 dimension, I could choose link value. Link value allows me to eliminate the parent-child relationship that an equation would create. So with link value here, I'm going to go ahead and specify height as the name of my link value. And now what that does for me is it throws an equations folder in the tree, and from the equations folder I can see my link value of height. Even if I'm only using that variable once, the fact that I gave it a name through linked values means I can see it in the tree. Aside from using linked value to show the name and the dimension in the tree, maybe I want to show the parametric nature of linked value by actually linking two dimensions together. As I double click on the stock feature, I can see the width and the depth dimensions. Maybe I want the width and the depth to be the same. So to add another linked value, I'll double click on the width dimension and I'll specify linked value. And for this, I'll call it equal width. When I do that, it's going to rename my width dimension to equal width. So as I double click to show that, there's my equal width dimension. And you can see that it has basically taken on the name of the linked values group. Now, to make that equal width also equal to this, or rather change the depth to the equal width, I just double click on my depth dimension, and from the pull down I'll specify linked value. From this pull down here I'll specify equal width. Once I do that, the two will be linked. In fact, the depth has been renamed equal width, and as I hit rebuild, you'll see that update. So now I can modify that dimension either from this equal width dimension or from this other equal width dimension. Now let's say I had a design requirement that this height dimension was not to exceed 1 inch. In order to dial that in SOLIDWORKS 2009 they added sensors. To add a sensor, you just right click on the sensor folder and specify add sensor. The type of sensors that we can add here are mass properties, simulation data, or a dimension. Now, in order to add a dimension sensor, you need to first show your dimensions. So I'll go ahead and cancel that and right click on the annotations folder to show the feature dimensions. Once I've done that, I want to make sure that my height dimension is there, so there it is. Then I can right click on my sensor folder, add sensor, and specify dimension, and then which dimension, this height dimension here, and ask SOLIDWORKS to alert me when the value is either greater than, less than, is exactly, is not greater than, is not less than, is not exactly. So in other words, if this dimension was never to change from 0.8, I could tell SOLIDWORKS to let me know when it's not exactly 0.8. So whether it's more or less, it'll warn me. But I did say I want to make sure that this thing is not going to be greater than 1 inch. So in other words, I can change this value as long as I don't go above 1 inch. When I hit OK, and as I rebuild here, I get one of the sensors going off. It says the following sensors have been triggered. Dimension 1 is less than 1 inch. Let's take a look at that. I think I might have set the sensor backwards. I wanted to make sure, okay, that this dimension is greater than. In other words, let me know when this dimension is greater than 1 inch. Okay, now that I got that straightened around, to test it, this dimension can get smaller, but if it goes over 1 inch, SOLIDWORKS will warn me when I hit OK and hit rebuild. So again, I can add design sensors to my file to make sure that specific dimensions that I'm concerned with are being watched. So again, this needs to be less than 1 inch in order to prevent my sensor from going off. And it looks like the sensors do require the rebuild up here, not necessarily the rebuild on the modified dialog box. And I think I'm done with these dimensions, so I'll go ahead and turn them off. To do this, right click on the annotations folder and show feature dimensions. And again, if you didn't want to see the dimension names, that was from the view pull down, dimension names. I'm going to go ahead and leave them on and hit rebuild. And with that, I'll open my next file And the next file that I have here is a casting. And on this casting you can see I've already renamed a few of the features. If I wanted to rename some of the dimensions, again you just select the dimension and specify the new name. And I got the length named, now I'll do the width. One of the reasons I might name my dimensions is for use in an equation. Now, because the view pull down for dimension names has been moved to the view pull down, this setting will be different for every single file. So even though I had it on just a second ago, it's not turned on here because this is a new file. So from the view pull down, I'll turn on dimension names, and now I can see the length and the width. Maybe I want to say that the width is going to be 1/5 the length. So that way if this thing gets longer, my handle is going to get wider. So to show that, I want to say that this dimension here is the dimension that's being driven by that dimension. So this dimension, the width, I want to add an equation. And here is where the advantage of renaming your dimensions comes in. I can see the name of the dimension. That's going to be equal to, let's say, my length divided by 5. So now I know exactly what this dimension or what this equation is doing. I can see that the width shall be equal to the length divided by 5, and that equals 20. That's the current value. However, if I change that length to, say, 120 and rebuild, then my width becomes 24. So now I've established a relationship between these dimensions using equations, and because I took the time to name my dimensions, I know exactly what my equation is doing. And now, for this casting, if I wanted to make a new part from it, maybe make the machine version of it, since it's going to have its own part number, when I make a new part, I can specify from the insert pull down, insert part. This allows me to grab my casting and drop it in. Now when I bring in a part to a part, I have a couple different options here. I can specify to bring in the solid bodies, any surface bodies, axes, planes, etc. Anything that my machine part will need. And now from here, I just simply drop in my cut features. So for example, if I'm going to do an extruded cut here, maybe I'm looking to make a hexagon cut. I then go ahead and add the appropriate dimensions and relations to fully define the sketch. Maybe make this through wall. Okay, now I have a finished part, so let me save this. I'll call it machined for insert part. And I can see in the tree here that it is linked back to my casting, which means that if I make changes to the casting, maybe change that handle to be longer, which in turn made the handle get wider. When I go back over to my machined part, it updated. Now I can predictably change my casting, and my machine version will update predictably. And as such, I could add a comment that says only add cut features to this part. Okay, and the reason that you would only add cut features to this part is obviously if this is truly a casting / machining type operation, then in order to add an extrusion onto this part here, that's actually telling the shop that they need to weld something to this part. So if you are going to employ this best practice, i.e. inserting a part into a part to represent a casting versus machined relationship, then you may want to add a comment that says you're only allowed to add cut features to this part. That way everybody will understand the workflow. Finally, I have one more part to share. I'm going to open this file. With my assembly here, I want to talk about a common problem, and that is as it relates to unique file names and descriptive file names. Now, we all like to have our descriptive file names, but here, as I'll illustrate in my assembly, all these parts have unique part numbers. Okay, now this will satisfy SOLIDWORks' requirement of unique file names. After all, if I named items plate 1, plate 2, and so on, by the time I get to my next project and I do the same thing, plate 1, plate 2, then SOLIDWORks could potentially grab the wrong plate number 1. So that's one of the reasons that we want to utilize unique file names for our parts. And what I want to illustrate here is, as I open one of these parts and I look at the file properties, here for the description, you'll notice that I have a descriptor. Now, when I go to save this file, I do have the option to specify the description while I'm typing in my part number. This description can show up in the tree. Earlier I talked about feature properties and feature descriptions, right? Found under the feature properties, I could specify a unique description. And I mentioned that through the use of your tree display, I could show the feature descriptions. Now, here's why you should care about this, and it is as it relates to the components. If I right-click and take another look at that tree display, I have the option to show component descriptions. As I turn that on, you'll see my file property description showing up there at the header of my part. Now I'm going to go ahead and turn this off because I want to show this over at the assembly where it's going to make a lot more sense. So let me go ahead and close this. And back over here at the assembly, as I scroll up to the top of the tree, I right-click on the name of the assembly, specify tree display, and now from here, if I specify show component descriptions, it's now going to go ahead and pull in all the descriptions from the file properties from each part. In fact, you'll notice that it has a bunch of items here. It has the part number, it has the name of the part, the description, and default display state 1. This is all under the tree display up top as showing the components configuration names, which was default. So as I turn that off, now I can see that that's gone. And if my display state names were different than default, then I could turn those off as well underneath tree display, show display state names. Once I've turned all that off, I can kind of minimize or clean up what's actually being displayed in the tree. In fact, if all I wanted to see was my descriptors, I could turn off the component names. Just right-click tree display, uncheck show component names, which is the file name, by the way. And now I have my descriptors giving me the best of both worlds. That is, having unique file names for each part and having descriptive names so I can find out what I'm working on in the assembly. Now, as I open this subassembly here, I did want to illustrate that earlier we used folders to group features together. Well, here in an assembly, I can go ahead and generate folders. Here I have my hardware put into a folder. To do that, you just simply select multiple items, and I'm just holding Control down here. And as I right-click on these parts, I can add to new folder, and I will call this one Cables. And now the advantage of putting these together in a folder is I could right-click the entire folder and specify Suppress, and it will suppress all the components within that folder. To bring them all back, I could find that folder, right-click, and unsuppress. So again, I could group like components together in folders and then have control over them simply by applying a command to an entire folder. And with that, I'll go ahead and close this subassembly. And with that, we'll get back into the slideshow. Communication tools, more on process documentation. We have items called tags. Tags will allow us to categorize features, parts, or assemblies. The idea of using a category means I could group multiple parts in the same category, or perhaps multiple categories on a single part. Some examples of categories could include the following. Perhaps the process performed per feature. So if I was trying to write an MOT, I could identify which features on the part were performed by which milling operation. I could categorize parts by whether they were purchased or manufactured, whether they're part of the electrical or mechanical system, or perhaps the vendor name. The advantages of using tags is it allows us to search by those tags, or for this example, categories. This also will behave like a power selection in assemblies. If I use the search at the top of the feature tree, I can type in a category, and all the parts that match that category will then show up in the tree. Everything else will be hidden. Now, tags all by themselves do not have much depth in SOLIDWORKS interface. However, I want to introduce you to SOLIDWORKS Labs. If you haven't been there yet, check out the website at labs.solidworks.com. Here they have thrown together some projects on future development for SOLIDWORKS, and one of the items that happens to be on the SOLIDWORKS Labs website is something called Tagger. Tagger is basically a plugin that enhances SOLIDWORKS tags immensely. SOLIDWORKS Labs Tagger puts your tags over in the task pane, which makes it easier to add tags to existing parts or features. And as it relates to power selection, if you click on a tag that's already been added, it will then select all the components that are part of that tag or category. Searchable items in SOLIDWORKS Explorer PDM, as I mentioned, tags, they're searchable, as well as file names, file properties, feature names, feature properties, and finally, folders. And with that, let's go into SOLIDWORKS. In order to use tags in SOLIDWORKS, if you look in the lower right-hand corner, you'll see the yellow tag icon. When you click on that, it opens the tags dialog box. You can drag the tags dialog to a more convenient location. In order to apply a tag to a component, simply select it from the tree and then type in the area to add the tag. You can see that I've already applied a few different tags to this assembly. Maybe this part is a purchase part, so I'll go ahead and specify purchased as a tag. The advantage of adding a tag here is if I go to the top of the feature tree and I start typing in that tag, such as purchased, then my component shows up. As a best practice, tags should be added at the part level. In order to see the tag again, you can click on that component and the tag shows up. In order to close the tags dialog box, if you click on the yellow tag icon in the lower right hand corner, it will hide the dialog. Next time you click to access it, it will be in the default location. Now, I do want to show you SOLIDWORKS Tagger, and this will be found at SOLIDWORKS Labs website, and let me take us over there. And the website is labs.solidworks.com. You can see that there are a few different projects up here that you may want to check out. The one we're talking about today is, of course, Tagger. In order to download it, you simply click on the download icon, save it, and install it. If you click play here, it will give you a short video on how this utility is used. Let's go back into SOLIDWORKS so I can show you how to use it. To save time, I've already installed Tagger. I'm just going to go ahead and add it in. Here it is, Tagger. What Tagger does is it lists all the tags that have been applied to this assembly. So as you click on the name of the tag, it shows you the components that have been added with that tag. In fact, as I click on electrical, you can see that purchased is half filled in. That means some of the components that have the electrical tag also have the purchase tag. The label tag has 18 different components. If I wanted to isolate all the components that are marked with the tag of label, I could then right-click out in the background and specify isolate. And now I can see all the components that have been labeled, or rather given the tag of label. I can exit isolate. In order to apply a tag with SOLIDWORKS Tagger, I'm going to go ahead and pin this open for a second. Simply click on the components that you want to add to the tag. So let's say this component here, I want it to be purchased. So I'll go ahead and click to add that tag to that part. Now when I click on purchased, that component is included in the purchased parts. Of course, if I wanted to add a new tag, I could type something here. To save these tags as a favorite, you can click in the star. What this simply means is as I go to open another file, these tags will remain in the tagger for use at that next file. I'm going to go ahead and unpin this. And in fact, I want to take us into SOLIDWORKS Explorer. Okay, over here in SOLIDWORKS Explorer, I first want to point out the options. For the search, you're going to want to make sure that it is looking in the folder that your documents are located. You'll also want to be sure that folder has been indexed. You also have other options like to have it start searching while you're typing, as well as include 3D Content Central results. In order to run a search, simply go up to the top of the program and start typing in your search criteria. As I type in label, it finds all the components that have label on them. And as I look at the part documents, you can see keywords of label. Those keywords, doc keywords, that is the tags that we applied. And with that, we'll get back to the slideshow. Next up for communication tools, visualization. Background images. You can import a TIFF image and use it as your background for a part or an assembly. To do this, simply use the Insert pull-down for Picture. Now, this background image is different than your scene background or your image file found in Tools Options for System Options under Colors. In order for your background image to show up, you need to make sure that your setting is set to either Plane, Gradient, or Image. Now, the image set in the System Options will be overridden by this background image TIFF that you drop in here. The primary difference between this and the image that you would set in the System Options color image is when you go to send this file out to a client, this TIFF file is embedded into the SOLIDWORKS document, so as long as their system settings are set to Plane, Gradient, or Image file, they will see your TIFF file in SOLIDWORKS. Sketch pictures. If you have an important concept image, whether it came from an industrial designer or something you found interesting that you may want to try to incorporate into your design, could be an interesting shape, maybe something organic that you wanted to try to mimic, you can insert these bitmap or raster images into SOLIDWORKS as a sketch object. In fact, if you size it properly, you can directly trace over the top of the raster image that will help in constructing complex geometry. This also works really well in reverse engineering older parts that you've manufactured that perhaps you don't have drawings for anymore, or the drawings that you do have are hand drawings that were scanned into the computer. You could, again, take these raster images and bring them into a SOLIDWORKS sketch, scale it, and then trace over the top of it. It could also be used to make quick representations of off-the-shelf parts that you plan on purchasing but cannot get a model for, nor can you get accurate size dimensions for. If you plan on making your own images for use as sketch pictures, then a lot of pre-processing before you bring the image into SOLIDWORKS will be required. In fact, if you plan on taking digital pictures of the parts you want to make sketch pictures out of, then you're going to need to make sure that you have a light background that the part is put on top of, so that way when you create your digital photo, you'll have a clear definition between the boundary of the part and the table behind it. Additionally, if you do get an image, then you may want to take it into a program like Photoshop and adjust the contrast so that way you can specify between light and dark and have clear definition of the edges for your shape. In fact, if you pre-process your images well enough, SOLIDWORKS does have an auto trace function. In order to use the auto trace function, you do need to add it in. It's found under the Tools add-ins. It's called auto trace. Keep in mind that when you do this, SOLIDWORKS is going to create splines to try to match the profile outline. If you're going to want lines and arcs, then you'll need to manually trace it yourself. But again, if you're just looking for a representation of a fairly complicated off-the-shelf part that you're going to purchase anyway, and you just want to represent it in your model for presentation purposes, then auto trace will probably do a good enough job for you just to get something that will represent this unique off-the-shelf part. The next item on here, sketch blocks. I threw this in here because when you're using sketch pictures and you're tracing images, you're going to end up with fairly complicated sketches in a hurry. A complex sketch is a sketch that's described as having more than one contour. So if you're manually tracing the images, you're going to be throwing in relationships and dimensions to define your contours. If you allow auto trace to trace the image for you, it's going to create a bunch of splines that have no relationships whatsoever. In either case, if you want to take that image that has now been converted to vectors and move it around, if you use sketch blocks, you'll be able to glue or lock those sketch entities together, and then you can manipulate them as a unit. So again, sketch blocks help either fairly complex sketches with a bunch of dimensions and relations that make SOLIDWORKS calculate with every rebuild, or on the opposite end of the spectrum you have a bunch of underdefined sketch entities, be they from AutoTrace or AutoCAD drawing files that have no real dimensions at all, but yet are dimensionally accurate. Sketch blocks will lock them down as a unit. Display states allow for clarity of assemblies or parts. Display states take the place of visual-only configurations. Now, when you're working with a large assembly and you have parts that are nested inside of other parts, in order to work on the parts in the middle of, let's just use a computer for an example. In order to work on the inside of your computer, you have to remove the case to get to the internals. To function like this, you might be tempted to make a configuration which hides or suppresses the case in order to work on the inside. But the problem with that is inherent to configurations, and that is when I make modifications to the current configuration, that's where those modifications are. If the top level configuration, which shows the case, isn't currently active, then when I go to the top level configuration, I'm going to need to unsuppress or show the items that I modified in order to have them come into the top level. And for this reason, SOLIDWORKS introduced display states in 2006. A display state is visual-only properties for assemblies, and now new to SOLIDWORKS 2010, they've added the ability of display states at the part level. These display states, for the very same reason they made them in assemblies, they've brought to the part mode, so those of you using weldments will be able to take full advantage of display states in the same way that you would have otherwise in complex assemblies. And finally, decals can be added to your parts for labeling and product identification. So for example, if you have stickers or decals or silkscreen labels that you put onto your parts, you can drop in a raster image onto your part file to show that. And with that, let's go into SOLIDWORKS to take a look at some of this. Okay, so back over here in SOLIDWORKS, I'll unpin the task pane. I can close Tagger for now. Now, I did want to mention one more time that at the top of the feature tree, this search will find tags, file property descriptions, or part names, that is the file names. So if I start typing in logo, it's going to go ahead and hide all the parts that do not match that search criteria. On the other hand, if I look for a tag, it'll find that tag. If I type in a part name, and since they're all named by part number, I'll go ahead and turn my tree display back on for component name. I can just start typing in a part number, and all the part numbers that fall within that criteria will show up. Everything else will be hidden. So again, whether it's renaming features or renaming parts, giving descriptions, this is all searchable from the feature tree as well as in SOLIDWORKS Explorer. And now let's go ahead and talk about background images. Okay, these knives here, you might recognize them, are from the movie Blade. They were produced by Factory X. If I was going to be sending a file to a customer and I wanted them to have my company logo in the background, you can do that. But to set this up, I did want to mention that from the Tools Options area, you want to make sure that the colors that you're using is set to plain or gradient. If it's using the scene background, it will not show the image that we're going to throw in there. So again, you need to make sure that the setting is set to plain or gradient here. And then to insert an image, use the Insert pull down. You'll find Picture. Now this is typically looking for a TIFF file. And here I happen to have a catalog page that Factory X did for these knives. So this shows really well with this particular assembly. And you can see it is a static image, so it will remain in the background. If I needed to change the background image, of course, use the View pull down, use the Modify and Picture, and from here you can delete the picture or replace it. But again, if a background image will help present your part, this is how you do it. Next, we're going to go ahead and talk about sketch pictures. What I have here is a panel that I want to mount a latch onto. And as mentioned, I could attach to the design binder the panel mount specifications, but maybe I want something a little bit more visual. I'm going to go ahead and edit the sketch here where I plan on putting the hole, and maybe I want to have confirmation that the design for this panel is correct for the latch installation. So to put an image into my sketch here, from the Tools pull down under Sketch Tools, you'll find Sketch Picture. A sketch picture allows me to drop in bitmaps, GIFs, JPEGs, PNGs, and TIFF files all into my sketch. And here I happen to have a TIFF file showing how this panel is to be prepared for the latch. So as I bring that in, I now can specify where the sketch picture will be located. I can click and drag to manipulate it, and I can also resize it. Just grab the corner. Now again, if I had an exact size in mind, I could just dial in the numbers over here on the left, but I'm just going to eyeball it, and then now I'll be able to double check that the latch installation hole is in the right location based on my spec. And then when I exit the sketch, that will be shown as long as my sketch is shown. If I hide my sketch, the picture hides with it. By the way, the sketch picture does show up as a separate entity underneath the sketch itself, and if you would like to hide the sketch picture, you can actually suppress that sketch picture. In order to suppress the sketch picture, you exit the sketch, and underneath the sketch you'll find the sketch picture. You right click on that and then specify suppress. Now when I go back into the sketch, the picture will be hidden until I unsuppress it. Now let's take a look at construction geometry using a sketch picture. Okay, so for sketch geometry creation, the first thing you need to do is find an image of the part you're trying to make a model of. And then you want to drop in your sketch picture. But here's the key to making this all work. As I edit this sketch here, I want to talk about scaling. Okay, the first thing you need to do is establish a size for your part. On this particular item, I know one dimension on it, 1.75. So when I drop in my sketch picture, I can size it. Now in order to size it, you just double click on the sketch picture and you'll be able to drag to resize the corner, and you can also position it by dragging it. Once you get this where you need it, both positionally and size correctly, then all you need to do is trace it. So in order to do that, I created a layout sketch here, and as I edit sketch on this, you'll see my trace lines based on the original image. Now, I moved the image around a little bit, but I think you get the idea that I was dropping in points and tracing right over this image. Now, one of the things to keep in mind when you're working with sketch pictures is your sketch colors, particularly when you're dealing with black and white line art. Black is hard to see over black line art, and we know that black sketch entities indicate that they're fully defined. Well, for this particular case, I would actually go into my Tools Options area for my colors and set my fully defined sketch entities to something else that would be easier to see. So as I find sketch fully defined, I can set that to be something a little bit brighter, like maybe orange, and now I can see my sketch lines over the black and white line art of my sketch picture. In this particular sketch, you'll see I have a bunch of sketch points with the fixed relationship, which is actually the only time I ever use the fixed relation is when I'm dropping in sketch points onto a sketch picture. The whole idea here is that I'm throwing in points on top of my image, so that way when I throw in actual arcs and ellipses, I can pass through those pinpoints, if you will. So that's just a little bit of a tip when working with sketch pictures. Again, I use the point tool, drop in a point right over the image and fix that point, and then run my arc through it. Now keep in mind, this is the long way to use sketch pictures. It's also the most accurate. As I exit the sketch here, you can see from my layout I went ahead and did an extrude and then finished out the part with various features. The easy way to use sketch pictures is to use the auto trace. SOLIDWORKS comes with an auto trace function, and in order to show that, I'm going to open another file. The next file that I have prepared for you has another sketch picture in it. Now, this is another tip as it relates to using sketch pictures. If you can control the source sketch picture, then I highly recommend taking it into a paint program and isolating just the contours you're interested in tracing. So you can see here I basically generated a silhouette off of that box image in order to find the contour that I want to trace. In order to use the auto trace function, you need to add it in. So from the add-ins area, you'll find auto trace. When you turn on auto trace, to access it, simply double click on the sketch picture, and these two blue arrows at the top of the screen indicate that auto trace is on. To use it, you just hit the next arrow, and then you use the eyedropper tool to specify the color you're looking for SOLIDWORKS to recognize. Okay, when I click on the black, I can then specify begin trace, and based on the settings below, it will try to map or match the black. I can change the contrast of the image. Again, if you have control of the source image like I did in a paint program, making a silhouette means that it's going to give SOLIDWORKS' Auto Trace the best chance at matching your shape. Now I can increase the tolerance or decrease the tolerance until you find something that looks fairly close. So here I'm going to maximize the color tolerance and the recognition tolerance. Maybe change my contrast again until I find something that I like. And then when you have something close, you hit OK. And that is SOLIDWORKS doing the work for me. It generates this spline, and now I can use that to make my part. Now keep in mind it does throw splines in there, so it may not be desirable geometry to begin with, but it is certainly a lot faster. Now there is one other way to extract vector shapes from bitmap images, and that is with the use of another program. If you're fortunate enough to have Adobe Illustrator, it does have a live trace functionality within it, but for the rest of us who want to get this and play with it, there is another option. There's a program called Inkscape. Let me take you over there to show that. To find Inkscape, which is an open source program, please go to inkscape.org. You can download it from the link here. Open source means it's a free download. You can find this and other projects at sourceforge.org. And with that, let me take you into Inkscape and show you what that looks like. In order to trace this, you go over to the Path pull down and specify Trace Bitmap. From here, I select my bitmap image, and then I specify what type. And by the way, this webcast isn't going to be totally training you how to use this. I'm just demonstrating it. Okay, when I select the mode I want to use, I click Update. When I hit OK, this program will go ahead and trace the image that I have brought into here. And as I close this, if I go to my view, I can take a look at what the outline made for me. And now here's the part that goes into SOLIDWORKS. I can go to File and save a copy. And I want to save this copy out as a DXF. And the DXF is found under Desktop Cutting Plotter. And then I simply give it a name and then save. Now the key to making this work, whether it's in SOLIDWORKS, Auto Trace, or in Adobe Illustrator Live Trace, or here in Inkscape, is to get the silhouette image of your file. Adobe Photoshop works great for this, or if, again, you don't have access to Adobe Photoshop, there is another open source program for that, and it's called GIMP. So as I go back over here to Internet Explorer, the address for this is gimp.org. That's GIMP.org. This is also another project found on sourceforge.org. And you can get this download from here as well. And with that, let's go over to SOLIDWORKS to take a look at the DXF output from Inkscape. So in order to use my DXF from Inkscape, I'll go to Open and change my file type to DXF, and from here I'll open the Inkscape export. Then SOLIDWORKS will ask me how to treat this DXF. I want to import into New Part, and in here I can see the vector line art, and in fact as I zoom in I can see that the outside contour looks pretty good, but the inside is pretty rough. let's go ahead and open it into a new sketch anyway. And from here, I'm going to go ahead and select all my sketch entities because I need to scale it down. However, as I select them all, you'll note that there are 757 sketch entities here to manipulate and change together. In order to move these as a unit, I highly recommend generating a sketch block. So from the Tools pull down under Blocks, you'll notice Make. This will generate a sketch block, and these items will be able to be manipulated and moved together as one. The advantages of this is this sketch block will now only be one entity in the sketch. So as far as performance is concerned, this will be really lightweight as opposed to the 750 plus entities that I had in my sketch before. Now the key to using this is, of course, the initial scale or the size of the real object. So for that, I'll go ahead and drop in a circle, and I'll locate it at origin. I'll want to go ahead and dimension my circle to 1.5 inches, or 1 3/4 inches rather. And then from here, I'll go ahead and drag my sketch block down and then scale it. Now I can scale it from the parameters area. It looks like I'm pretty close. Let's take another look here. Not quite there, so I need to go a little bit smaller on the scale. .05 may be a little much there. Let me try one more time. Let's try 0.75. Okay, for this example, that's pretty close. Good enough for now. And then I would simply go ahead and extrude this. So I'll go into Features and Extrude. And using selected contours, I could go ahead and select the inside contour. Go ahead and set a depth and hit OK. And as I take a look at this, we noted that the original DXF inside contour was a little rough. The outside contour looked okay, so I may want to go into that sketch and eliminate one of those contours. Or, of course, if you spend more time in Inkscape, as I did with this other DXF here, I exported with black and white turned on, import into new part. These contours are a lot cleaner, and of course I can extrude from here as well. Again, a little bit cleaner, so you can either clean it up in the program you're tracing it from or right here inside of SOLIDWORKS. Now I'll go ahead and bring up the next file that I have to share with you. As I mentioned, display states are for display-only attributes, whether you're working on an assembly or now in 2010 if you're working on a part. In an assembly, the example I gave is working on a computer. If you need to work on the inside of the computer in and around the motherboard, you need to hide the bezel or the case out of the way to get to it. Well, in earlier versions of SOLIDWORKS, that is 2005 and prior, you would have had to generate a configuration to suppress all those components for quick, easy access between being able to work on the inside of the computer versus the outside. Well, the problem with doing that is it relates to configurations, and that is to say any of the changes that you make at the configuration belong to only that configuration. Therefore, when you go to the top level config showing all of your components, you'd have to unsuppress all the work that you just did. Well, in 2006 when they introduced display states, that was no longer a factor, because now I could have my configurations for my design changes and display states to control my visual attributes. Things like hiding components out of the way, or maybe even specifying what display style to have that component shown in, whether it was wireframe, hidden lines removed, shaded or shaded with edges, all mixed within the same configuration. And with SOLIDWORKS 2010, they brought that functionality to the part mode. This is going to be really helpful for those of you that are using weldments and you have the similar type of scenario where you need to hide a bunch of exterior plates to get into the inside of your assembly where you're welding additional structural members on the inside. We'll now be able to specify display states to hide those plates and structural members out of the way and make your changes on the specified configuration. Now, to share this concept, I have a football helmet here, and for those of you who may recognize it, this is a helmet that you would get out of the grocery market quarter vending machines. And what I want to share with you is that I could have multiple configurations as I do so here, and with those configurations I could have different color variations of this part within each config. So on this current configuration I have a red helmet with a white mask, I have a white helmet with a gray mask, and I have a powder blue helmet with a black mask. Now these display attributes for the current configuration allow me to specify multiple color combinations without changing the part itself. After all, configurations are for a right hand versus a left hand version or items similar to that. Here I get to specify a different configuration for my helmet, in this example an older style mask, and here I could have color variations based on this configuration as well. Now we also have the ability to link display states to configurations. If I uncheck this, I can see all of the configurations that I have at this part, which will then be available at each configuration. So for example, if I double clicked on red helmet with white mask, I can see the old style mask configuration with these color combinations. Now I may want to have a display state where I hide a body out of the way, in this case the mask. I can right click on that and specify hide, and so now my display state here could be no mask, and then of course to show or bring the mask back you just double click on one of the other configurations. I'm going to go ahead and leave the display states linked to the configurations for the moment, and I'll go ahead and generate one more display state. So I'll add one more, and on this new display state I want to change the color of the part. And when I specify a color for the part, I want to make sure that I'm changing only this current display state. And I'm going to go ahead and choose a gold. And then I'll go ahead and change the mask here. And on this I want to change the body. And for that maybe I'll choose a green. And then I can rename this display state by slow double click or hit F2 on the keyboard. Call it yellow and green mask. And with that I want to talk about decals. Now on this configuration here you'll see that I have a decal applied, and rather than getting into describing how to apply decals, I want to take a moment and point out my PhotoWorks 2008 webcast. I go into extreme detail on how to apply decals. The reason I'm not going to take the time right now to describe this is the fact that PhotoView 360 will be the replacement product for PhotoWorks, and as such PhotoWorks is being phased out. However, currently PhotoView 360 does not support adding decals, so I can't exactly show you how to add decals in PhotoView 360 since it's not there yet. So again, I just want to direct your attention to our webcast archives and look up PhotoWorks 2008, and in there I will describe how to add decals. Now, the reason you want to use decals is as it relates to product identification or part marking. You could go ahead and put your company logo on your part, and then when somebody goes to open it, they will see your decals. Which, by the way, in SOLIDWORKS 2010, decals are now supported whether or not PhotoWorks is turned on or added in, or whether or not they even have PhotoWorks. So anybody with a standard SOLIDWORKS seat will be able to see your decals. In order to see the decal from the view pull down, about halfway you'll see decals. And also with SOLIDWORKS 2010, eDrawings will save out your decals. And with that, we'll get back into the slideshow. Communication tools, exports. Although SOLIDWORKS can save out many more file types than the ones listed here, these are some of the more common. The preferred file format to export from SOLIDWORKS is a parasolid. So if you're sending your part to other people using SOLIDWORKS, specifically when they're using an older version of SOLIDWORKS, then you want to send them a parasolid. One of the advantages of sending a parasolid, if it's an assembly, is the parasolid will maintain the part's colors within the assembly. The next best export from SOLIDWORKS is the step file format. And then one of the more common and also problematic file formats is called IGES. Some systems won't take in parasolids or steps. And then finally, for 3D data, an STL export is primarily used for rapid prototyping and 3D printing. When you export files, keep in mind that there are options that you can set. Items like the default coordinate system, maybe the format version, or the document units. One of the advantages of using a different coordinate system is if you import a file from another CAD system and the origin is nowhere near where you need it. After all, we need to remember that the origin is the intersection of the standard three planes, and perhaps moving the origin closer to the part so it's usable. For example, in an assembly we can use planes for mating. If the origin was placed in the middle of your part, you could then center that part in your assembly, but let's say the import you have has the origin 3 feet away from your part. If you import the file, you could drop in a coordinate system and then export it again through Parasolid using the new coordinate system you just dropped in. Then when you re-import that Parasolid, the origin and the standard planes will be right where you specified. So now you can take advantage of your standard planes for mating in an assembly. If you're going to export 2D data, then DWG and DXF are the recommended formats for this. Keep in mind, for the options, we can save out older versions of AutoCAD, as well as specify the scale and how to treat your splines. So again, if you're going from SOLIDWORKS to SOLIDWORKS, Parasolid is the preferred file type for bringing back into SOLIDWORKS. And with that, we'll take a look at this. In order to save a file out for another CAD user who isn't using SOLIDWORKS, when you do File Save As, you can change your Save As type to multiple different file formats. The ones I'm talking about here is STEP and Parasolid. Parasolid is the recommended file format for exporting to another person using SOLIDWORKS, for example, an older version. If I click on Options here, I did want to point out that you can specify which Parasolid version. You have the option to flatten assembly hierarchy, so this would eliminate your subassembly structure. And then we also have the option to save out to a different coordinate system. Now I have another file set up to describe the coordinate system, so let me go ahead and open that one. And here's a common problem. If you're getting files from another vendor and their coordinate system 000 is not in the middle of the part, where you may want to take advantage of the planes for this part for mating, provided the standard planes are running through the middle of the part, you may want to drop in a coordinate system. And in order to do that, you simply use the Insert Reference Geometry pull down for coordinate system. Then you go ahead and specify new coordinate system. So if I wanted my coordinate system to be in the lower right hand corner of this part, I could do that. And then when I go to save this file out and I change my file type to either Parasolid or STEP and take a look at the options, here I get to set the coordinate system output. So once I do that and I bring it back in, Again, I got to change my file type to Parasolid. And now once I've brought the model in, I can see that the origin is where my last coordinate system happened to be. So if you get an export and the coordinate system or the planes are not where you want them, go ahead and drop in a new coordinate system, save it out as a Parasolid about the new coordinate system, and then bring it back in. And then this will be good to go. Now, if I did want the coordinate system in the middle of this part, then I may need to drop in a sketch, perhaps draw a center line corner to corner. Okay, then drop in my point here in the middle. That way I have something to reference my coordinate system on. So again, insert reference geometry coordinate system, specify the origin, and then when I do my file save as here, and then when I do my save as here, I can specify again Parasolid about that coordinate system. And again, when I do that, it'll put that coordinate system in the middle. So let me do that one more time. And now when I open it, again changing to Parasolid, that coordinate system will be right in the middle. So now my planes will be in the middle of my part for mating. So again, just because somebody sends you a file, a dumb model, or a dumb solid, and the coordinates is not where you need them, you can always go ahead and round trip it through Parasolid to place those planes in that origin where you want it. The next file that I have to share would be a drawing. And if I wanted to export 2D data, when I do a file save as here, I could specify DXF or DWG. Now with these, again, make sure you look at the options. I can choose which AutoCAD version to save out to. I can specify the output scale, specify how to treat endpoints, maybe export my splines as splines or as polylines. I can export the active sheet or all the sheets onto one file, or perhaps all the sheets to separate files. And with that, we'll get back to the slideshow. Communication tools, exports. The following exports are recommended for clients or partners who do not have CAD at their disposal. The number one format is going to be Adobe PDF. Acrobat Reader is available as a free download, and most businesses already have Adobe Acrobat Reader installed on their systems. The PDF, which stands for Protected Document Format, can export 2D and 3D data. The PDF also has some options here. If you look at the export options screen, we can export a PDF in color. We can embed the fonts, use high quality lines, specify the DPI for the shaded geometry, print the header and the footer, and use specified print line weights. Now, as we export in color, you'll notice that the shaded draft geometry DPI, when you select that option, export in color, it will convert that PDF to a raster image. A black and white PDF will come out as vector. A raster image can be described as a grid of color. When you zoom in really tight, you'll be able to see the individual color squares that, when combined together, make up your image. Vector images, on the other hand, is coordinate data. SOLIDWORKS produces vector graphics, and so long as your PDF is black and white, it will output vector graphics. Another universal file format is the TIFF image file format. This is the common format for exporting images from scanners and digital cameras. It is recommended over JPEG because TIFF is a lossless format. But keep in mind this will produce a raster graphics format. TIFF can also save out multiple pages in the same file. So if you're going to save out a drawing as a TIFF file, each page will be preserved in a single TIFF file. In order to specify which pages are saved out with the TIFF file, you simply need to go into the options when saving as TIFF and specify a print capture. Then you'll be able to specify which pages are saved out with the TIFF file, as well as the output DPI. And finally, SOLIDWORKS provides a free 3D viewer called eDrawings. It's also worth mentioning that eDrawings is a native SOLIDWORKS viewer, so if your client who does not have CAD loads this eDrawings viewer on their computer, you could send them your native SOLIDWORKS files and they can use the eDrawings viewer to look at them. However, much like the PDF, the protected document format, if you save an eDrawing, then that data will be protected in the fact that they will not be able to reverse engineer your file from the eDrawing so long as you did not enable measure with the eDrawing. So as I talk about enabling measure for eDrawings, if you look at the export options for eDrawings on this slide here, you can allow somebody to measure the eDrawing file or not. You can allow export to STL for the part or assembly contained in the eDrawing. This would be used for 3D printing purposes. You have the option to save the shaded data in the eDrawings file. You can save table features in the eDrawings file. That would be things like bill of materials or title blocks. And if you have a motion study within that SOLIDWORKS file, you could also have the eDrawings file, copy that along with it. With eDrawings, your client will be able to review your drawing, hit play to watch eDrawings cycle through the views, and they'll be able to stop the playback at any time and freely rotate your model, as well as hide or isolate parts within an assembly for greater exploration of the data. And now with SOLIDWORKS 2010, eDrawings will save out your decals. Another advantage to using eDrawings is the markup and measure capability. So while you're communicating with your end customer, if they would need to make changes to your file, again, and do not have CAD at their disposal, they can mark up your file and send it back to you, and then you can make the required changes in SOLIDWORKS. So it's invaluable for the back and forth between you and your client on the project. Markup and measure includes adding notes, comments, even drawing circles, splines, or adding dimensions, even inserting images for clarity. You also have the ability to add stamps to eDrawings, things like not for manufacturing, or draft, confidential, or for internal use only, just to name a few. You can also make your own stamps. Now, if you do enable measure, then the recipient of the file will be able to measure all aspects of your model. This is appropriate when you have a contract in place, or for internal use such as the shop. If they need to take a look at my SOLIDWORKS files and they need a quick dimension, as long as I've enabled measure in my eDrawing file, then they'll be able to measure it. Do keep in mind that if you use eDrawings to open a standard SOLIDWORKS file, then they will be able to measure it by default. In order to preserve your data, you need to save out an eDrawing file with OK to Measure disabled or turned off. Aside from measure, you'll also be able to section the model so you can see what's going on inside. And with that, let's go into SOLIDWORKS to take a look at this. Okay, if I wanted to save this file out for a non-CAD user, I can do Save As, And a couple options here for non-CAD user would be an Adobe Photoshop file, an Adobe Illustrator file, an Adobe PDF, or a TIFF file. Now if I save as TIFF, some of my options here, I could specify whether or not it included all the sheets. So this would be a multi-page TIFF file. I could specify the DPI settings as well as the output paper size. If I go to save this out as a Adobe PDF file, the options that I have here are whether or not to export the PDF in color. I could specify the shaded views DPI setting. By the way, if you have any shaded views on your file that you're saving out as a PDF, it will convert those views into raster images. Black and white line art drawings will go out as vector graphics, which simply means they can zoom in on the drawing view and it will be crisp and clear. But your shaded views, they will be converted to rasterized pixels. Okay, so that's what this DPI setting is for. So keep that in mind. If you do want to save out shaded views, that will be the cost. Relative to PDF on an assembly file or a part file, as I go ahead and open this one here. When I save this out as a PDF, we have the option to save as a 3D PDF. Let me go ahead and save that. And let me go ahead and open that PDF. This PDF will be a 3D model. And so long as your client has Adobe Acrobat Reader 7 or greater, they'll be able to see these models. You can zoom in, zoom out. They also have options like setting the render option so they could see a solid illustration, shaded with edges essentially. Illustration. Illustration is like a black and white view. Now keep in mind these 3D PDFs can get quite large. I'm going to go ahead and close this. And this I'll close out. And then of course the next best item to save out is going to be e-drawing. Now when you do an e-drawing, I'm going to do a save as really quick to talk about the options. For the options here, if you want the client to be able to measure this e-drawing, in other words they could reverse engineer the file, then you need to check it on here first before you publish. So you need to do a file save as, change your type to e-drawings, go into the options and specify it's okay to measure this e-drawing. Then that option will be available when you go to save it from a publish e-drawing. You could also do things like allow an STL export. You'll notice it's grayed out right now because I have a drawing. I could save shaded data in drawings, and the rest are as it applies to tables and motion studies. And now I'm going to go ahead and publish. And now here in e-drawings, I could specify play. This will basically cycle through all my drawing views. I can at any time stop and then rotate. I can jump back home. Now the advantage of sending an e-drawing over a PDF is the fact that they'll be able to mark up and make comments on your file so you can make changes. In fact, when you send it out, you can specify stamps. You know, things like confidential, just drag that stamp on. These stamps cannot be removed once they're saved into the file. Okay, I could remove it right now while I'm creating it, but once I save as an e-drawing, then it'll be stamped in there. In fact, you can make your own stamps. You just specify a stamp file path. And of course, to remove a stamp while you're putting them in, just select on it, hit the delete key. An e-drawing will save out all your sheets. And of course, if you enable markup and measure, they'll be able to measure as well. Just specify activate measure and then click on the items you want to measure. And in order to make sure that the measure is available, when you do your save, you specify enable measure and whether or not to save with the shaded data. When you go to save it, by the way, the different file types that we can save out as, either a native e-drawing, which means they'll need to download and install e-drawings in order to see this file. But keep in mind that native e-drawings is a SOLIDWORKS viewer, so you could send them native SOLIDWORKS files and they will be able to use e-drawings to view them. I could save it out as an e-drawing zip file. This will package the e-drawings viewer with your file. However, it will make your files larger. You can save this out as an HTML. This will enable them to open this in their web browser, provided they download and install the plugin for e-drawings for their web browser. Or you could save it out as an exe file. However, most email clients will block executable files, so if you're going to use that one, you may wind up needing to change the extension and then giving the end user instructions on how to put the exe back on there once they get it past their firewall. And with that, I'll go ahead and save it, enabling the measure. The last thing that I wanted to mention about e-drawings was in regard to decals. So I'm going to go back over to SOLIDWORKS, and I'm going to go back over to my file that has a decal, and when I publish this out as an e-drawing, I'm going to go ahead and specify all configurations. E-drawings will take over your decals that were applied in SOLIDWORKS. Okay, so for all your product marking or labeling, you have to send an e-drawing to capture these decals, and this is only valid in SOLIDWORKS 2010 or newer. And here's how e-drawings treats your configurations as tabs at the bottom. And with that, we'll go ahead and close this out and get back into the slideshow. Also, I just wanted to let you know that DDI is trying to reach out to all of our customers, so this is our avenues of communication with you. You can follow us on Twitter. You can find our Facebook page. We have a YouTube channel. We usually post 5-minute video tips there. It's going to be youtube.com/digdimcad. You can check out our podcasts on solidworksherd.com, or you can join our microblog site, herd.solidworksherd.com. And once again, I'd like to thank you for joining me on another DDI Productivity webcast. To find this and other archives, please visit our webcast archive site at webcasts.ddicad.com. I'm your host, Joseph Richter. Thank you, and God bless.